Good day, viewers all over the world. You are welcome to Toidel online class. So today we want to consider questions and answer. Question in form of multiple question that asks like objective question. So multiple choice questions. That is, if you question that required little or question that you can actually solve without much calculations. That is, there's some question that when you're looking at the question, you should be able to get the answer within a few seconds. So those are the type of questions that we want to consider today. So and today we are going to base on indices, question on indices, logarithm, surds, cells, and if time permits, and probably complex numbers. So I want us to be attentive and let us make use of the comment section. If there's anything that you don't understand, just type on the comment section. Or if you have further questions on multiple choice question that in form of objective that required less calculations, you can just write it. You can just write it on the comment section. I promise to go through it and reply. So I want to start the question and answer section. So let me start. I want to start by introducing the first question. So, like this first question now, the question says we should simplify the cube root of 8a raised power minus 6. So, this type of question does not really require much calculation. Even me looking at this question, you should be able to guess the answer. If you are very vast with the law of indices, you should know that this will be, here I should give it to you, that will be 2a raised power minus 2. That is 2 all over a square. That will be the answer. So these are, you see, we there's need for us to actually go through all what we have done. So the law, we just retain some of this law offhand, so that me looking at the question, it's computer based examination. Is that the one you call JAM or CBT, whatever examination? If you are very vast with the law of indices, then you would require little effort to be able to solve this. So we are given the cube root of 8a raised power minus 6. So how do we approach this? Of course, if you don't really want to stress yourself, just rewrite cube root. Of course, cube root, when you have cube root of a, is same thing as a raised power 1 over 3. If you have quart root of a, that will be a raised power 1 all over 4. Okay, but if you have square root, it is a raised power half. You understand? So with this now, we can just rewrite what we have here and say this is 8a minus 6, everything raised power 1 all over 3. This is same thing as this. Okay. Then since the denominator of this power is 3, now let's think about how we can rewrite this 8 as index of 3. That is, that gives us what? 2. 2 in 3 places is 8. 2 times 2, 4. 4 times 2, 8. So I'm going to write this 8 as 2 raised power 3. Then a raised power minus 6, everything raised power 1 all over 3. This cube root covers everything. So the implication is that I'm going to have 2 raised to power 3 multiplied by 1 all over 3. We find the cube root of a, multiplied by a raised power minus 6 multiplied by 1 all over 3. This 3 can take care of this 3. 3 here 1, 3 here 2. At the end of the day, we are going to have 2 multiplied by a raised power minus 2. So it now depends on the nature of how the question is given. So the final answer will now be 2. This is 2a raised power minus 2. I can write this and say 2. This is the negative form. If I want to write this in positive form, that will be 2 all over a squared. So just go ahead and pick the right option. Okay. If you have a raised power minus x, it's same thing as 1 all over a raised power x. So if you have the negative of the exponents of the index. If you want to write it in the positive form, it will be reciprocal. That is 1 all over what you are given. So this will be the answer. So as I've said earlier on, if you are very vast with the law of indices, you don't need all these steps. Just look at, can I write this 8? You think about the denominator here. Okay, can I write this as index of something raised to power 3? That is 2. So 2 in 3 places, 3 we cancel 3. You know the first one is 2. Then 3 here 1, 3 here 2, a raised to power minus 2. So we are going to spend less than maybe 6 seconds. You solve this. That is why I will advise that we should go through all the videos on simple exponential equation in this. That is where I treated indices, law of indices, and introduce some simple exponential equations. So that is the first question. It is very simple. So any question in terms of indices, you should be able to solve it. Let's get another question still under indices. So like this, simplify. We have 75a squared b raised to power minus 2 all over 5a cube b raised to power minus 3. This also, you don't need much stress. The first thing is that this, we first deal with the coefficient. 5 here 1, 5 here 1 in 25. That is 5. So that is 15. Then you now apply the law of indices. You know, this is a. There's a at the numerator. There's a at the denominator. What is the power of a at the numerator? 2. In indices, when you have division, s raised to power a divided by s raised to power b, the law says that it will be s raised to power a minus b. So if it is addition, multiplication, s raised to power a multiplied by s raised to power b, the law says that it will be s raised to power a plus b. So since this is the division line, it is negative that we introduce. So we have a raised to power 2, a raised to power 3, there, that will be a raised to power 2 minus 3. Then we go to b raised to power 2. You know, this division also automatically will give us minus here. Then what do we have at the numerator of minus 3? That will be into bracket minus 3. So from here now, we are going to have 15. A into bracket 2 minus 3 is minus 1, a raised to power minus 1. Then we have b minus 2. Minus times minus is plus. So I'm going to have plus 3. That is, I'm going to have 15 a raised to power minus 1. Minus 2 plus 3 simply means 3 minus 2. That's b raised to power 1. And that doesn't make any sense. You just say this is 15b. I can bring down a because it is negative, it's reciprocal. A all over a. And that will be the answer. So from this exception now, without going through this process, if you know the law of indices very well, of course, you just go ahead and get your answer. 5 here 1, this 5 is 7, 5 is 15. Then you know that this is a. 2 minus 3 is minus 1. So 15 a raised to power minus 1. Minus, you know, the minus times minus plus, this b. So from this question now, you can jump to this step. So that is why it is expected that you should go through everything about law of indices. No, of course, we also have law of logarithm. Just let's make sure that we are versed with this so that we'll be able to solve all these multiple choice questions with little stress. So we don't need to stress ourselves. We can actually get all this. So let's take another question. So let's take this question under logarithm. Simplify. The question looks longer, but it's still very simple. Plus, it's all about your ability to recall the law of indices and logarithm. That will actually help us. This is what you are given. You know, in case of law of logarithm, when you have log a plus log b, it simply means log a times b. When you have log a minus log b, it simply means a minus a divided by b. So if you now put the law into practice here, you know, they have the same base, 3, 3, 3. So we are free to operate with the logarithm. So I'll just write log 3. Then wherever I have addition, I multiply. When I have division, when I have subtraction, whenever I have addition, multiply, subtraction, you divide. So this is going to give me 2 times 81 divided by 54. That's what we're going to get. It's as simple as that. Based on the law of logarithm, that I think you know, there's a video for logarithm. We have video on logarithm and logarithmic equations. So based on that, we are free to do this. And of course, Can we do, what can we get? What are we going to get here? I'm going to say this is log 2 times 81 is 162 divided by 54 base 3. Can 54 divide 162? Yes, because when I say 3 times this is going to give me this. So I'll say 54 here 1, 54 here 3. At the end of the day, I'm going to have log 3 base 3. If you have a log and the base, if they are the same, the answer is 1. Once the logarithm and the base are equal, the law says that it is 1. If you have log 1, irrespective of the base here, either base 2 or base 10 or base x, it is 0. So these are some of the laws of logarithm that we have considered and what we have discussed in a former class. So just try and go over the video for you to be able to recall some of these formulas. So if you are given something like this in multiple choice question, even without writing anything, without any calculation, you should be able to tell us the answer. Since the base are equal, just say 2 times 81, that's 162, divided by 54, 3. Log 3 base 3, 1. Just get your answer. But if you don't know the law, if you can't recall the law of logarithm offhand, you won't be able to solve this. You will not be able to solve this. So let's take another question. We take another question. Please, if you have any question, just type under the comment section. I'll be checking the comment section so that I will know if I'm to go over any other thing, because it's just a section for question and answer. So I don't need to be too fast here. So I want the class to be interactive in this sense. Okay. So we can also have, okay, let me introduce one question on complex number. So the question says simplify 5i raised to power 5. Look at 5i raised to power 5. 5i raised to power 5. Of course, under complex number, we know that I squared is equal to minus 1. I is equal to square root of minus 1. So I squared is equal to minus 1. Then I have I raised to power 5. This same thing as 5. I can split this I now. If I squared is equal to minus 1, then that means that if I have another I squared, it's equal to minus 1. I squared times I squared, law of indices, I will have I2 plus 2. That will be I raised to power 4. It's going to be minus 1 times minus 1. That's 1. So I can split this I raised to power 5 to I raised to power 4 times I. Any question? Law of indices permitted me to do that because these bases are equal, and this I simply means I raised to power 1. I'm going to add the base. I'm going to add the power or the index. The base are equal. So here I'm going to have 5. What is I raised to power 4? I raised to power 4 simply means I squared times I squared minus 1 times minus 1, and that gives 1. So I raised to power 4 is 1. So I'm going to write 5 times 1 times I. At the end of the day, the answer will be 5i. So if you have to simplify this now, the answer is 5i. So without any calculation, we should be able to look at this and say the answer is 5i without any problem. Okay. What if we are not given? Say the question just says simplify maybe 15 I raised to power 4. Without any stress, you should be able to say this is equal to 15 because I squared is minus 1. So how many I squared do we have in I raised to power 4? That is minus 8. That is 2. Twice of this. This times this, minus times minus plus. So I'm going to say I squared is equal to 1. Then 15 times 1 is 15. So under multiple choice question, objective based questions, most often time, all the questions that you will be given required short steps to get your answer. So in less than say 30 seconds, you should be able to get the answer because you'll be given maybe less than 30 minutes to attempt like 35 or 40 questions. So we need to be very fast and be vast with some of these concepts. Like this now, I squared is equal to minus 1. You should know that. So these are some of the concepts that you should know offhand so that there won't be any problem. Then there's this question also that I want us to treat. Like in this case now, you said given that log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771. So that's what we are given. The question now says evaluate log 1064 log 6410 plus log 2710. So during logarithm, we said that if you are not given any base, you assume the base to be base 10. So in this case now, we are given the base to be 10. But let's assume that we are not given any base. Just say log 2 equal to this, log 3 equal to this. The base should be assumed to be 10. That is the standard. Okay? Except when you have natural logarithm. That is when you have log e. That's in x. That will be in 2. If this log e, this will give us in 2. That's natural logarithm. But otherwise, if you are not given the base of any logarithm, you assume the base to be base 10. So in this case now, we are given 64, log 64, we are given log 27, but we are given something in the form of log 2. So you will think very fast that can you rewrite 64 as index of 2, something 2 raised to power something. Then when you have 27, can we change it to 3 raised to power something? That's what you first think. It is possible. We not say solution, we just say log 10, log base 10. Then what is this log 64? What is 64? Can 2 divide 64? 2 is the factor of 64, yes. Then that's the means that this can give us 2 raised to power 6. Because 64 is 8 times 8. 8 times 8 is 64. Then what is 8? 2 raised to power 3. Multiply by 2 raised to power 3. We have 2 raised to power 3. Multiply by 2 raised to power 3. This is 8 times 8, which is 64. Then law of indices, the base are equal. Just say 2 raised to power 3 plus 3. That's 2 raised to power 6. So instead of log 64, I'll change it to 2 raised to power 6 plus log 27. 3 can divide. 3 is a factor of 27. Can divide 27 without remainder. So I'll just say 9 times 3 is 27, right? What is 9? 3 squared multiplied by 3. That will be 3 raised to power 2 plus 1. 3 cube gives 27. So I will change 27 to 3 raised to power 3 base 10. Okay? So this if you are given something like this, this is how you think along this direction. Okay? Then when you consider, please, I want to admonish us that we should go through the videos on each of the concepts, because once you know that, at least we are going to learn it by heart. I didn't subscribe to cramming, but I believe that repetition enhances learning. When you keep going over a particular concept over and over again, it becomes part of you. So in this case now, there's one law. I think the third law of indices says that if we have log AB and A has its power, the power can come down. That is, you can have 6 log 2 base 10. There's a law that says that this in logarithm. There's this 3 can also come down. We have 3 log 3 10. Then just say 6. What is log 2 10? We are given the value is 0.3010 plus what is log 3 10? We have this value. 3 into bracket 0.4771. Then from there, you can go ahead and get your answer. 6 we multiply this, so we are going to have 0601.8. Then plus 3 we multiply this, we have 3. 3 times 7, that's 21. 23. 3 times 4, that's 12 plus 2, that's 14. Then when you add these two together, of course, I'm going to have 3, 7. This is 3, 7, 3. The 4, this is 2.3. That will be the answer. So we were able to solve this now because we know the law of logarithm that says that if you have log a base b raised to power x, the law says that this x can come down to have x log ab. So please, I want to advise that we should just go over the video on simple exponential equation, indices, and logarithm. So once you are familiar with all these rules of indices and logarithm, then you hardly have problem under this concept. The first thing is for you to know the law. Then the second thing is for you to now be able to apply the law that you have learned. So practice, constant practice will actually will help you in that area. So now let's see question 5, question 6. The question says simplify These are short questions that required, these are questions that require short answers. 3 plus 4i plus minus 2i plus 5. Of course, when you have I high, if you know it's under complex number, I high is talking about imaginary part of that complex number. This is the real part. The one with I is talking about imaginary. So in this case now, what do you do? Of course, you had real to real and complex to complex, imaginary to imaginary. So in this case, I'm going to have 3. You know, this is plus here. Of course, it has no effect here. I will have 3 plus 5, then plus 4i, plus times minus is minus. That will be minus 2i. So at the end of the day, I'm going to have 3 plus 5 is 8, plus 4 minus 2, that's 2, 2i. That will be the answer. So without writing anything here, you should be able to solve it. Just look at it. So most of these multiple choice question does not require any calculation if you are very vast and you understand all the concepts very well. Just mere looking at it, you get your answer. So as I've said earlier on, we are going to concentrate on indices today, logarithm, surds, complex number, and probably set theory. So those are the areas that we are going to concentrate on. Please, if you have any question based on the 6 questions that we have treated, just write it on the comment section. I promise to be very slow today. So I'll go and check the comment section now. And if you have any other problem that you think you cannot solve, just put it at the comment section. So if I'm unable to address it today, then probably tomorrow I'm going to handle that. So that's what I promised you guys, and that's what I'm going to do. So that is that about that. So let's take another question. Let's take another question. Okay. Question 7, still under indices. The question says simplify 1 all over 4 into brackets 2n minus 2n plus 2. Look at this now. Of course, this question is under indices. Anything raised to power is under indices. So in this case now, what do? Since you have all this, the base is 2, 2. What you have outside here, you can change it to 2. Because 2, of course, 2 times 2 will give us 4. So instead of 1 all over 4, I'm going to change it to 1 all over 2 squared. Because 2 times 2 is 4. So I can write 4 as an index of 2. 2 in 2 places is 4. Then into brackets 2 raised power n minus 2 raised power n plus 2. Of course, I can bring this 2 raised power 2 to the numerator. That is, I said something the other time. If you have s raised power minus 1, say minus 2, it's same thing as 1 all over s squared. So this, if you want to remove the negative sign here, it becomes the reciprocal of what you are given. So if you have it like this now, 1 all over s squared, you can bring s squared to the numerator, just that it's going to attract a negative sign. The power will attract a negative sign. It's part of the law of indices. So in this case now, I'm going to rewrite this. I'll say this is the same thing as 2 raised power minus 2. It's still the same thing. It's law of indices. Then multiply by 2 raised power n minus 2 raised power n plus 2. So I can open up. I'm going to use 2 raised power minus 2 to multiply what you have. Now check, the base are equal. So once the base are equal and you want to use multiplication, you multiply, you just add the power. When you divide, you subtract the power. So in this case now, I'm going to have 2. 2 want to multiply this first one. That will be, I'm going to get 2 minus 2 plus n. That's what I'm going to get. Then minus this 2 raised power 2 will also multiply what I have here. I'm going to get 2 raised power minus 2 plus n plus 2. That's what I'm going to get. So when you open up, this is what you get. And of course, I can rewrite this as 2 raised power, instead of minus 2, I can change it to n minus 2. Then minus, this is 2. Minus 2 will take care of 2 here. Then that will be 2 raised power n. And that will be the answer. This will be the answer. And of course, you can rewrite this just being 2 raised power n outside the box. But we can just you stop at this point. So if any of the option, you have this as any of the option, just stop. But if they simplify further, the only thing they can do there is to bring out 2 raised power n here. If we bring out 2 raised power n, we are going to have 2 raised power minus 2 here, then minus 1 here. That's what you get. So it's either you have it in this form, or they decide to simplify further and have what you have there. Okay? So the first thing that you should develop is confidence on the inside that you can solve it. So if you are given any problem, if you develop a confidence, if you have confidence on the inside that you can solve it, then that is when your brain begin to boot. And of course, the empty brain cannot bring out anything. No. You must have read, you must have prepared very well, know all the laws, the rules by heart. Law of indices, you should be able to recall everything offhand. Law of logarithm, the rules of surds, and some of the concepts you have under complex number, everything. You see, we also talk, we talk about talk mathematics. Mathematics is the language that we speak. So the more you practice, so I didn't learn this overnight. We learn, we learn it in actually we actually learn bit by bit. So from this question now, I can determine the answer without going through this process. I'll just change this to 2 raised to power 2. Then I know that this will be 2 raised to power minus 2. Once I introduce this, I'm going to get 2 raised to power n minus 2 minus 2 will cancel to 2 raised to power n. Without going through this process, I will know the answer. And that is what I actually want us to do when you have multiple choice question. So it is expected that you should look at it very well and get your answer in less than 10 to 15 seconds, because you'll be given a shorter time to attempt CBT. So all these computer-based tests, you have to be very vast and get your answer on time. So that is how to simplify that. Okay. Then, so let's look at another a question. Evaluate. The question says evaluate 5 all over square root of 2 minus I. You see, when you have I, it's talking about complex number. So if this is complex number, then of course we are going to rationalize. This will be 5 all over square root of 2 minus I. If you rationalize this, we are going to rationalize with the conjugates of this sort. Conjugate simply means when it is minus here, you change it to plus. If it is plus here, you change the sign to minus. So I'm going to have square root of 2 plus I all over square root of 2 plus I. Then if that is the case, 5 will multiply the numerator. We have 5 into bracket square root of 2 plus I all over of the denominator is very straightforward, but let me just expand. So I'm going to have square root of 2 times square root of 2, that is 2, plus square root of 2I. This will give us minus square root of 2I. The minus times plus is minus. I times I is I squared. So this will take care of this. Square root of 2I minus square root of 2I will cancel out. Then at the end of the day, I'm going to have 5 into bracket square root of 2 plus I. Then all over 2 minus, what is I squared? I squared is minus 1. So I'm going to have minus 1. I squared is minus 1, right? So that is what we're going to get here. So this is 2 plus 2I minus 2I plus times minus minus I squared is minus 1. So I'm going to change I squared to minus 1. I squared is equal to minus 1. Then minus 1. You know, the operating sign there is minus. So instead of going through this denominator like this, you can just say square root of 2 all squared minus I all squared. So we are going to have 2 minus I times minus I. That is I squared is minus 1. Okay, minus that will be plus. Then here I'm going to have 5 into bracket square root of 2 plus I all over 3. And that will be the answer. Okay, so that will be the answer. So let's just try and go through the videos. So let's learn everything bit by bit so that we'll be able to solve any given multiple questions. So let's take another example. Okay, look at this example now. It's under logarithm. Evaluate log 2510 plus log 3210 minus log 810. So in this case also, once you look at this, you don't need to solve anything. Automatically, I know that the answer is 2 without solving anything here. Then this is what you do. Just say log 10, log, then base 10. When you have plus addition, you multiply. You're going to have 25 multiplied by 32. So where you have subtraction, you divided by 8. 8 here 1, 8 in 32, 4. So at the end of the day, I'm going to have log 25 times 4, 100 base 10. I can write this and say this is log 10 raised power 2 is 100. 10 times 10 is 100, all over 10. So I can bring down these two according to the law of in the logarithm. I now have log 10 base 10. When you have a log, if the log and the base are equal, the answer is 1. So I'm going to have 2 multiplied by 1, and the answer is 2. So I just want us to know that under multiple choice question, especially when it is CBT, you don't really have time to be doing all this analysis. Just look at the question. If the base are equal, when you have addition, multiply. When you have division, and when you have addition, you multiply. When you have subtraction, you divide. Of course, you just say 8 here, 1, 8 here is 4. 4 times 25, 100. This is base 10, 10 squared. The answer is 2. So you can just go ahead and get the answer without any calculation. Okay, but it will be based on your knowledge of logarithm. If you don't know law of logarithm, then what I'm saying is not as easier as that. But I want you to actually go through all the videos so that there won't be any cause for alarm. So out of the question, if you are given, let's say 50 multiple choice question, at the end of the examination, you should be able to assess yourself. At least if you know what you are doing, you should be able to say that out of maybe 70 marks or something, I can get 60 or 70 in this question. You can even get 70 or probably 100. It depends on how vast and how fast you can be. So these are some of the tips that we use under multiple choice questions. So let's take another question. Let's take another question. Okay. The question says, if 3 raised power 2s is equal to 27. So find x. Look at this. This simple exponential equation. You know what? Once you have equality sign, it's talking about equation. But if there's no equality sign there, you just simplify. But once there's presence of equality sign, what you have is an equation. So we have to solve. We'll solve here. So this is 3 raised to power 2x is equal to 27. Of course, since the base here is 3, rewrite 27 as index of 3. So we are going to have 3 raised to power 2x as 3 times 3 is 9. 9 times 3 is 27. So I'll change this to 3 raised to power 3. So if the base are equal, you equate the power. That's the law. And if the power are equal, you equate the base, vice versa. Okay, that has been the standard. So because this is base is 3, this 3, you go ahead and equate. You said therefore 2x is equal to 3. Just equate the power. And in a situation whereby the power, the index are equal, equate the base, is vice versa. Then there, you divide both sides by 2. So x is equal to 3 over 2. So look at when you can check 3 multiplied by 2. If x is equal to 3 over 2, 2 we cancel 2. What do you have? 3 raised per 3. It's not 27. So this type of question does not really require any calculation. Mere looking at the question, you can actually predict the answer. But you must know the law of indices very well. So that is just it. So we take another example. Then after this example, I want to go through the comment section and see if there is any question there. Or let me go through the comment section and know what is going on. So let's take question on 11. Let's take question on set theory. So there's this information that if P is equal to 2, 1, 3, 9, 2.5, these are the elements of P, and we have Q to be equal to 1, 2.5, 3, 7, and we have R to be equal to 5, 4, 2.5. So the first question now says that we should find P union Q union R. Of course, we denote sets with capital letter, and element of a set, the entries with small letters. But in this case now we have it in the form of digit. When we talk about union simply means the union between P and Q simply means the element that you have in U, or you have in Q, or you have in both. So if you have the element in both, just pick it once. So that's the meaning of union. the union of a set. There's a video under set theory 1 and 2. So set theory 1 actually explain all these concepts, cardinality of a set. But set theory 2 is talking about Venn diagram. So I have video on that. You can go through some of the video on Toyden online class. So in this case now, P union Q, of course, since you want to find P union Q, union R, just write it like this. Now check it. Let's start from 1. You have 1 here. You have it here, but we don't have it in R. We pick it. Just say 1. We have 2 here. We picked 1. You have 2 here. You don't have it here. You don't have it here. We pick 2. We have 2.5 here. We have it here. We have it here. You just pick it once without repetition. That's the meaning of union. Union simply means is that you have the element in A, in P, or Q, or R, or the element is in everything, is in both, but you only pick it once. So we have 2.5. So we've picked 2.5. So you just take it. Then after 2.5, we have 3 here. We have 3 here, but we don't have it here. We pick it. So after 3, what else do we have? Okay, we picked 2. So we go ahead and pick 4. There is 4 here. We pick 4. There is 5 here also. We pick 5. Then we have 7 here. We pick it. Then we have 9 here. We pick it. So P union Q union R will be what we have here without repetition. Because if you have 2 in all the 3 sets, then you only pick it once. You don't say without repetition. That's the meaning of union. Then the second question says that we should find, let's say this is question 12. We should find P intersection Q intersection R. So in this case now, intersection simply means you must have the element in both P and Q and R. That's the meaning of intersection. The element must be in all the sets under consideration. So in this case now, let's see. We have 2 here. We don't have it here, so we won't pick 2. 2 is not in everything. We have 1 here. We have 1 here. We don't have it in R. So that nullifies that. We have 3 here. We have 3 here, but we don't have 3 in R. So we won't pick that. We have 9 here. We don't have 9 here. We don't have 9 here. So we have 2.5 here. We have 2.5 here. We have 2.5 here. So 2.5 actually is common to all the 3 sets. So we say 2.5. So do you have okay? We have 7 here. We don't have it here. We have 5 for here. We don't. So the intersection will just be 2.5. Intersection simply means all the elements must be in all the sets. But when it is union, is that you have it in one of the sets or in both or in all the 3. But you have to pick it without repetition. So that is that about union and intersection of a set. So after this next question, I want to quickly go through the comment section to know if we have questions or we have complaints. So after this question, we are going to have we have a little break. I want to check what is going on the comment section. -3 all over 2. Look at this now. It's still under indices. So when you have something, if the power is fractional, most of the time just look at the denominator of that power. Then it is the denominator that will determine what will happen here. Since I have square here, 2 here, I'm going to rewrite this 16 as index of something that is square. That is, when I say 16 is divisible by 4. 4 is the factor of 16 because 4 times 4 is 16. So I'll just say 16 raised to power -3 over 2. I'm going to change this 16 now to 4 squared. 4 squared, 4 times 4 is 16. So that will be multiplied by -3 all over 2. 2 will cancel 2. I'm going to get 4 raised to power -3. That's what I'm going to get. And I can write this in positive form. It will just be that once I remove the negative, it will be in form of reciprocal. Then I'm going to have 1 over 4 raised to power 3. And of course, if this is one of the options, just pick it. Or I'll say 1 over 4 raised to power 3 is 4 in 3 places. 4 times 4, 16. 16 times 4, that's 64. So 1 over 64 will be the final answer. So without this step, I can, from this question, I will know my answer. Mere looking at it, I know that the answer is 1 over 64. Because I've just changed, in my mind, I've changed this 16 to 4 square. 2 will cancel 2. I will have 4 raised to power -3. That will be 1 over 4 raised to power 3. And that is 64. Okay. When you have multiple choice question, it is very simple to actually solve multiple choice question, provided you are versed with the rules and regulation, the laws that actually guide the topic. Okay, so I want to quickly go over the comment section to know if there are questions there or if there are complaints there. So let's have a short break. I'll be back. I just want to check the comment section. Okay, so I've checked the comment section. So some of the comment I said here is talking about the Mobius theorem. So the Mobius theorem is a concept under complex number. So probably tomorrow. So maybe before the question and answer class tomorrow, I will come online and discuss the Mobius theorem. Then somebody talked about mathematical induction. Actually, I've taken that. I have a video on mathematical induction. So by the grace of God, tomorrow we are still going to have question under mathematical induction. So we are going to have this question and answer period for like 3 days. So we still have time to consider most of these concepts. So I promise to come up with a lecture teaching on the Mobius theorem. So the Mobius theorem is just the generalization of complex number in polar form. So that is it. So we are going to do that by the grace of God. So I've seen the comment section. So let us continue from where I stopped. So we are still going to have this question and answer section tomorrow. So I'm going to come up with so many questions there. So this one says simplify log 381. Still without doing anything here, I know the answer is 4. Because of my knowledge of the law of in the law of logarithm. So since the base is 3 and 3 is the factor of 81, so I'm going to write this 81 as index of 3. That is, I can say this is log base 3. 81 is 9 times 9. 9 times 9 is 81. 9 is 3 raised power 2. Multiply by 3 raised power 2. I'll add this. I'll have 3 raised power 4. 2 plus 2 is 4. So I can change 81 to 3 raised power 4. So I can change 81 to 3 raised power 4. And if that is taken, one of the law of logarithm says that this power can come down to have 4 log 3 base 3. When you have a log and the base to be equal, the answer is 1. So I'm going to have 4 times 1, and the answer is 4. So as I've said earlier on, without any calculation, once I look at this, I know the answer is 4. And that is the level I actually want each and every one of us to get to. But how do we get there? We must go over the video on each concept. If you want to know about it, just like somebody that has question on the Mobius theorem, you must first understand complex number very well. You know the forms of complex number, that is the standard form, the polar form, and the exponential form, and the logmatic form of complex number. Then once you understand that very well, then the Mobius theorem is just generalization That's that about the Mobius theorem is just generalization. So, but if you understand all this concept very well, you won't have any problem under the Mobius theorem. So we take another question. We take another question. We take another question. So look at this now. This is another question. We have to solve 4 raised per x is equal to 0.5. Of course, 0.5 is 5 all over 10. 5 here 1, 5 here is 2. That's half. So I'm going to get 4 raised per x to be equal to 1 all over 2. I can write 4 as index of 2. I'll change 4 to 2 raised power 2 into bracket x is equal to 2 raised power minus 1. If I take this to the numerator, then I'm going to have 2 raised power 2x to be equal to 2 raised power minus 1. The base are they are equal. We equate the power. So I will now say 2x is equal to minus 1. Then divide both sides by 2. So that x is equal to half minus half. And that's the answer. So without going through this process now, from this question, I know my answer. That my answer is x raised power minus 1. Because in my mind, I know that 0.5 is 5 all over 10. That is half. Then that half, I can change half to 2 raised power minus 1. Then this 2x, when I write this 4. So the answer is minus half. So even if you want to go through this step, in less than 10 seconds, you should be able to get this answer. And that is how multiple choice questions are being designed. You don't really have the time. It's different. So when you are dealing with CBT, you just have to be very fast and vast. Then there's this question. Evaluate is 0 factorial. So this factorial is under permutation and combination. Permutation and combination is a concept. I'm not sure, but I think I have a video on it. And if I don't have video on it, then I think I will need to I need to teach this. So this is just the elementary part of permutation and combination. So this factorial simply means you just write what you have from to get to 1. So is 0 factorial is 1. So that's the standard. Then when you have 1 factorial also is 1. Okay, so without any calculation, you know that when you have 0 factorial is 1. 1 factorial is also 1. So so I think I'm going to take about 2 classes tomorrow. One on the Mobius theorem, then the other one on permutation and combination before I bring up questions on permutation and combination. I'm not sure, but I think I've spoken about combination when I introduced the binomial theorem, because we use combination to expand to find the factors under binomial theorem. So I will need to come up with on a class on permutation and combination. But just note that when you have factorial, is 0 factorial is 1. That's the standard. Then 1 factorial is also 1. So please note that. Note that when you have 0 factorial is 1. 1 factorial is also 1. Then let's take another question on surds. In this case now, you have to simplify, or you say evaluate 2 root 3 plus root 27 minus root 3. So in this case now, we have to rewrite this 27. Can we break down 27? Root 27. Square root of 27 is same thing as square root of 9 times 3. So square root of 9 is 3, right? So I can change square root of 27 to 3 root 3. So from there, I will say this is 2 root 3 plus, instead of root 27 now, I can write it as 3 root 3. So this will be 3 root 3 minus root 3. That's what we have. So these are similar surds now, because root 3 is common. You have to rewrite this in form of similar surds. So this is root 3, root 3, root 3. So 2 plus 3, just like when you have x as the coefficient. 2 plus 3 is 5. So this can give us 5 root 3 minus root 3. Root 3 is 1 root 3. So 5 minus 1 is 4. So the final answer will be 4 root 3. And this is what we expect to get. So from the question now, without going through this process, I can get my answer. I'll just write this as a similar sort. So 27 will be 3 root 3. So 2 plus 3 is 5. 5 minus 1, that's 4. The answer will be 4 root 3. So we can just look at it and get the answer. straight away. So, so we take 2 or 3 more questions, then we close for today. We continue from there tomorrow. So another question is where you have simplify 16 all over 81 raised to power 1 all over 4 divided by 9 all over 16 raised to power minus half. Okay, so this is what you get. So just look at this question. As I've said earlier on, when you have question under indices, and if the power is fractional, just look at the denominator. It is the denominator that will tell you. This denominator will actually guide us on how to express this. This is the denominator in the first part is 4. The denominator in the second part is 2. So if I want to express this 16 and 81, I'm going to write it as an index of 4. That's what I'm going to do. So in this case now, I'm going to change this 16 now. Since it's raised by 4, I'll change 16 to 2 raised by 4. Because 2 in 4 places is 16. So I'm going to have 2 raised by 4 divided by 81. 3 in 4 places is going to give us 81. 3 times 3, that's 9. 9 times 3, 27. 27 times 3 is 81. So instead of 81 now, I'm going to change this to 3 raised by 4. Then everything raised by 1 all over 4. Divided by this second part now, the denominator of this power, of this index is 2. So I will reduce this to 3 raised by 2. Then I change this to 4 raised by 2. So I'm going to have 3 raised by 2 all over 4 raised by 2. Everything raised by minus half. So from this now, the numerator is raised by 4. The denominator is raised by 4. So I can combine the two to say 2 all over 3. Everything raised by 4 is the same thing. Multiply by 1 all over 4. Divided by, in this case also, I will say 3 all over 4. Everything raised to power 2. Multiply by minus half. 4 will cancel 4. 2 will cancel 2. So what we are left with 1 here. So the answer will now be 2 all over 3 divided by 3 all over 4 raised power minus 1. So please note that if you have the index to be raised to power minus 1, the implication is that you are going to reverse what you are given. If I want to simplify this now, this simply means that if I want to remove this minus now, I will bring the denominator to numerator and numerator to denominator. I will exchange. That's the implication, because this simply means 1 divided by 3 all over 4. That's the meaning of what we have here. Then if once we want to change division to multiplication, we are going to turn it over. I'm going to have 1 multiplied by 4 over 3. So from here now, I will change this now. I'm going to have from here, I'm going to have 2 all over 3 divided by, instead of 3 all over 4, everything raised by minus 1, I'll change the 4 over 3, as we have seen it here. So this will be 4 all over 3. Then finally, I'm going to have 2 all over 3. When I change this, I'm going to have 3 all over 4. 2 will cancel 2. Then here 1, here 2. The final answer will be half. The final answer will be half. So just look at it very well. Once you apply the law of indices, you should be able to solve it. Then I take 2 more questions, then we call it a day. So now let's take the question on this. Look at this one where we have log 1 all over 6 base 6. Without going through any stress here, this answer is minus 1. Without any stress. Just look at it, you know the answer is minus 1. How do I get that? I'll just say, when I have 1 all over 6, it's same thing as you saying log 6 raised by minus 1 base 6. If you have 1 over 2, it's not the same thing as 2 raised by minus 1. So the reciprocal, if you want to take it to the numerator, just it attracts the negative sign. Okay, so in this case now, minus 1 can come down. I have minus 1 log 6 base 6. Log 6 base 6 is 1, so minus 1 times 1, and the answer is minus 1. So these are some of the simple but intelligent questions that you can actually come across. Okay, then I will take the final question for tonight. We are going to continue from there by the grace of God. So given log x9 is equal to 2. Find x. In this case now, this x now, x can be equal to 9 raised to power 2. So that is the relationship between index form and logarithm log form. Please check the video under logarithm and logarithmic equations. So there's a relationship. If you are given log x base n base 9 equal to 2, the law says that this your base will be raised to the power of the result. It's going to give us the log. So now x will now be equal to 9 times 9 is 81, and that will be the answer. So I would love to stop the class because of our time. So we have actually discussed more on indices, logarithm, the introductory part of complex number, and some question on surds and set theory. So I actually want you to go through the videos, so learn most of the rules and laws of what we have discussed. So by the grace of God, tomorrow we are going to concentrate on theory of quadratic equation. We talk about binomial expansion. We take question on partial fractions. We talk about matrices, inverse of matrices, then probably Cramer's rule, and what we are able to do tomorrow. So we are going to take this question and answer section for just 3 days. So thank you for listening, and God bless you all.